In this video, I'm going to look at a normalization exercise for the PartyLite company. So the PartyLite company sells candles. So they have customers buying candles, but they do this by that certain customers decide to host parties. And then at those parties where they invite their family and friends, their family and friends then become customers, additional customers to the PartyLite company, and they take some orders. So we're going to walk through this normalization exercise, but it's always good to have in mind sort of like some expectation. And so one of the well-known database examples that people are exposed to in a database course is the Northwind database. And I'm bringing up a ER diagram of that. And let's just look at what they have. They have customers and orders and something called order details and the products. So we're going to have to expect something along this line. And then we have this additional concept of the party. So we're expecting some kind of order, some kind of customer, order details, products, and then maybe something along the line of a party. Okay. Um, Now, here are the fields given so far in the normalization exercise. The party is somehow identified with a party ID. It was on a particular date. It was held at some address. We know who the host is. Then at that party, there were customers. The customers are assigned an ID, and they have a name, and they have an address and a phone, and they pay in a certain way. We have to decide if that's a function of the person or a function of the order. And then they buy, instead of calling it products here, it's called items. Okay. So we want to, first thing we want to do is put it in first normal form by flattening the table. So we're not going to explicitly do that, but we're going to imagine that we have here a list of items, and we don't want that in a database. So that each one of these would have to be made an explicit record. And so this would have to be divided up into 3 rows. And then we see for a given party or host that there are a number of customers. So that would have to be, again, sort of broken out in to get into the first normal form. We don't want any of these multi-valued fields. Okay. And then we want a primary key. Remember, the job of the primary key is to uniquely identify each record. So one step is always that the repeated thing, something that identifies the repeated thing, the listed thing, I should say the repeated thing, the listed thing, the list of things, something that identifies the listed thing must be part of the primary key. Because these, when we turn this into 3 separate records, it's the item, the distinct item in each one that's going to be distinct. All of the customer information, the party information is going to be the same. So we know down here, and then of course we'll choose the ID, that item ID is going to be part of the primary key. And then we start saying, like, is that enough? It depends on the nature of the relationships. So knowing the item, is that enough to determine, say, the customer? And the answer is no. We see here that customer 1 bought some cherry votive candles, and customer 2 also bought some cherry votive candles. So knowing the item ID does not tell you the customer ID. So we would need the customer ID. And then we ask, sort of, is that enough? And then we have to sort of think beyond sort of just the data that we're shown and imagine, do we have, a candle, something that you use up, that you burn down? And so then if this person bought some candles and liked them, then they might order more candles at a later date. So just having that customer having bought that item is not sufficient to identify the record. So we would add, uh, in this case, we'll say the party ID. Now we're making an assumption here that the the customer only had sort of one order in the party or something like that. Okay, but that we're thinking is enough to identify the record that uh, the customer had one sort of order in the party. So at you don't write up the order to the end of the party and then the person you know is all the things they're ordering are part of this. So we're thinking this might be enough. The party ID, the customer ID, and the item ID might be a primary key for this. Now, if we look back here at, we're expecting to get somewhere along this idea. So they have North Wind, they have a concept of order. Now we're going to need some kind of concept of order, but we don't have an order ID. So that's like one question here. Do we want to introduce an order ID? So let's say we did. So the next question is about candidate keys. So if we introduce um, if we introduce based on our sort of insider knowledge about this pattern that we know that might arise from the north wind, we might introduce an order ID, and then we might come up with order ID and item ID. We know we're going to need that here, and we need to know what the order is. We need to know what the item is. There's more than an item may be in many orders, and order may have many items. So that's a many to many. So we know we need both of these. But the order for us would determine the customer. A customer may have many orders, but an order has one customer. So customer is sort of implied in there. And also party is probably implied in there, that the order came from a party. So the a party may have many orders, but an order comes from one party. So if we introduce an order ID, then we just might need two composite two fields to make up our primary key. So that's one possibility here for a candidate key. And what could be another if we didn't have that idea of introducing an order ID? Then we might say that the host and the date. If we think that a host only hosts one party a day or something like that, then maybe host ID and date could replace the party ID or something like that. So maybe instead of keep item, keep customer, and then replace party ID with like date and host ID or something like that. So different possibilities here for primary keys. Let's just stick with what we got. Although I'm tempted to go with this order ID, I will stick with what we've got. Okay. So let's look next for functional dependencies. Let me get myself onto the next page here. Okay. Now, clearly the item ID tells us, again, functional dependence is almost like a mini primary key. So the primary key is going to uniquely give us everything else in the record. So the combination of item ID and customer ID and party ID, from that combination of things is unique for each record, and we can look up everything else. concept of a functional dependence is that idea, but like a smaller. Like if I know the item ID, I can figure out the item description and the item price. Tell me the item description and the item price. It won't tell me the quantity. I don't know. Just you tell me the item. I don't know how many they bought, but it does tell me, if I know it's I0011, item 11, I know it's a lemon votive, and I know it's 5.99. Now, it's possible sometimes to put the price with the item, and you might also put it with whatever concept of order you have, because maybe the price will change in one way or another. You don't want the price on an order to change. They've ordered the lemon votives, and that price of the day they're ordering, we hope won't change. That would not be nice to change the price after they've ordered them. But maybe we have inflation and the price goes up, or maybe within the sale, or maybe within the order there was like a sale price. So um, we're going to put item price with item, but it's conceivable that one might put it with order, and it's conceivable that one might have it both within item and in the order, to sort of recognize that the price has some kind of base current item, some base current price, which would be in the item table, and then what was the price on the day of that it was actually ordered, if in case there was a sale or in case the price has changed. Okay. We're not going to make it that complicated, but just the things I've seen, and they're not unreasonable. Okay. What else do we have here? So item ID was giving us item. Okay. Customer ID was clearly giving us, what do we have up there? Customer name, customer address, customer phone. And what we have the payment type. So we've got to say, is that a function of the person or is that a function of the order? Let's say they might have paid cash one day and then they didn't have enough cash the next time and they paid with a check or a credit card. So let's leave that as a function of the order. Okay. Then we have what? The party ID. Party ID. And that was telling us the date. And host ID, we know who post, not hist, but host. And what else was up there? Party address. Okay, party address. We're making the assumption here that somebody may, the host of the party, it may not be at their address. So it might not be their customer address. They might go, I don't know, to their mother-in-law's house and host the party there. So they are the host, but it's not necessarily their address. That's the address of the party. Anything else up here? Okay. So we want to know what um, the customer and the party, as sort of a combination, are what here in North Wind would have been like the order ID. So let's ask, what does that, so so the customer ID and the party IDs, that sort of combination is giving us the order. And what up here was a function of the order, pay type. So you pay, that was a function of the, did we leave anything out? We had date, party address, host ID were determined by something, customer name, customer address, customer phone, pay type, item description, item price, quantity. I think I need all three parts of my primary key to determine the quantity because the party ID and the customer combined are giving me the order. And then I need to know what item they're ordering, and then that will tell me the quantity. So the quantity is sort of all three. So let's just write it explicitly. So we will say that that gave us the quantity. Okay. And if there were a sales price or something like that, then that might also determine the sales price if we are keeping um, price as part of like the order details, if you will. But we just put the item price with the item and kept it simple. Okay. So we have sort of almost everything being determined somehow or other by things. If we had introduced the concept of order ID, then order ID would have given us the combination of customer ID, party ID. So I haven't, just going to say here, if I had introduced order ID, then it would have told me, not the, yes, it would have told me the customer ID and orders by one customer, and it would have told me the party ID. The order came from a particular party. And then those things we know in turn determine other things, the customer name, the party, the host, the date. So up here with this approach to the primary key, these were all partials. But if we had decided to go with order ID, then some of these would be transitive. So I'm just going to keep to the original and say here, those were all partials. They had partial dependencies on the primary key. Item ID was part of it, was part of the primary key, customer ID, party ID. Um, these are all part of the primary key, so these are all partial functional dependencies. With the primary key we sort of stuck with, then we would say, no, there are no transitives. But had we introduced an order ID, which is not necessarily a bad idea, then we would have had then we would have had the some transitives because the order ID would have told us something like customer ID, which would have then told us other customer information. Okay. So sometimes whether you're decomposing at the second normal form or the third normal form depends on your choice of the primary key. All right. So we want to start to decompose. So I'm going to try to grab everything if I can do this. Just to put up here as sort of a reminder to myself. Make sure I have everything, make sure I don't lose any fields, make sure I don't lose any relationships. Okay, so I'm just saying here are all the things I have. Now, I am looking to, at second normal form, to pull out an item, or you might also call it a product. I'll call it an item to be consistent with the nomenclature here. And we expect that to have an item ID, an item description, an item price. We will say that the item ID was the primary key. So that was the normalization approach told us to pull out this, to pull out the this partial dependence, to pull out a customer. So clearly a customer ID and customer name and a customer address. I think there was, and customer phone. And the ID was the primary key. Okay. What else are we supposed to be pulling out? We're supposed to pull out a party. This is the one thing, the one idea in this database that was not in Northwind. So I'm going to have a party. Just going to have a party ID. It's going to have a date, a host ID, a date, and a party address. A date, a host ID, and a party address. And party ID is going to be the primary key. And we're going to designate the host ID as a foreign key connecting us to the customer table. So the customer can play a role of host in a a customer may host many parties, but a party is hosted by one customer. And so that's a one-to-many relationship. And so we have host ID here in the party table. Okay. What are we looking for? We pulled out item, we pulled out customer, we pulled out party ID. We're pulling out customer party pay type. And this is what I'm going to call order. But instead of introducing order ID, I'm going to use customer ID and party ID as a composite primary key. Again, could have introduced order ID, but decided not to. And then the payment type was a function of the order. And so we know who ordered, uh, and we'll get the date from the party. So if we need to know the date of the order, the party will relate us to the date of the order. We know who ordered, and then we need, as Northwinds has always told us, the relationship between order and products is many to many, and an order may have many products. A product may be in many orders. So we need that bridge table. We can call it order details. Some people call it order line. You might call it order item to tell you the two names of the tables you're connecting. I think I'll do that. I think I'll call it order item. And we know that that needs the order ID. Um, and I don't have an order ID. I'm using this combination. Might be better if I introduce an order ID, so I have to think about it. But for now, I'll just stick with what I've got. Probably paste for some reason. So keep identify the order by the combination of party ID and customer ID. So we're thinking about introducing an order ID, and then what else is in order details, the product ID, which we call the item ID. And that's where the quantity went. Okay, so do we have everything? Date. Date is here, party ID, party address, host ID, customer name, customer address, customer phone, pay type, item ID, item description, item price, quantity. We have all of our fields. Do we have all of our relationships? Have we lost anything? We should not lose. We should be able to have joins and get back to where we were. So we can, up in that original table, it was by party, so we can query a party and get that information. Then we can find, so we can start with party like the table did, find the party and get the host information. Then we can use the uh, party ID and find uh, the orders for that party. So we start with the party and then we get the orders for that party. So that will take us to the customer information. And then through order item, we can get the items. So we have something like this, customers, order details, products. And then we have another thing called uh, party, which is the relationship between like orders and party, that the orders come from a party and the party is a location. And then there was a relationship between the party and customers, like one of the customers was the host of a party. So there's another entity in our thing, which is this party, and it has sort of a connection to order. We can see that here, and that party ID is part of our primary key for the order table. This was also for order item. That's also part of the primary key. So, um, so we, other than, so mostly we reproduced this with adding in a party entity. A party had a relationship to an order, then an order was taken at a party, and party had a relationship to customer. That there's a customer who hosts the party. I think we have all of our relationships intact. And I think we'll call it there. Thanks for your attention.